Okay, for this problem you definitely want to use log properties to break it up. So that's the first thing that we're going to do. First thing we can do is bring the ln 10 down in front of the log. Also keep in mind that that's a log base 10, so your a value here is going to be 10. Okay, so first thing we'll do, log properties. We're going to do ln 10, and then that's going to be times log base 10 of sine x secant x over e to the x times 3 to the x. Okay, so this is going to be your first step, is bringing that ln 10 down in front. But now we want to break this log up further. So I'm going to leave the ln 10 on the outside, and then everything that's on top of the fraction is going to be left positive. Everything on the bottom is going to have a negative in front of it. So I'm going to do log sine x plus log secant x. So again, breaking that up with a plus. But these two, when we separate it, they're going to have a negative sign because, again, these are both in the bottom. So I have minus log e to the x minus log 3 to the x. Okay, so that's expanded as far as I can go with logs. Now this part right here does not cancel. If you had ln e to the x, that would cancel out and give you an x, but there's a log base 10 here. It's different. So if the bases are different, you can't cancel that. So this is as far as you can go with that one. We're now ready to take the derivative. Now I'm going to leave the ln 10 on the outside and then just take the derivative of each of these separately. Each of these is going to require u primed over u ln a formula that we talked about earlier in this section. So for the first one, okay, I have u primed goes on top. The derivative of sine x is cosine x. On the bottom, we have a u, which is sine x, times ln a. I mentioned that if there's no number there, it's a base 10, so you're going to have ln 10 down there in the bottom. Next, I have the u is secant x. That's going to go on the bottom. And then again, I have another ln 10 down there. On top, I've got a secant. The derivative of secant is secant x tangent x. Okay, that's u primed. Next, I have e to the x. Okay, on top I have u prime. The derivative of e to the x is e to the x. On the bottom I have u, which is also e to the x, and then times ln 10. The last one, 3 to the x. Okay, now on the bottom I have the u, which is 3 to the x, and then I have ln 10 again. Now on the top I want to do the derivative of 3 to the x. We talked about that earlier. The derivative of 3 to the x is going to be the same thing, 3 to the x, but then times ln of its base. We're not going to use ln 10, we're doing the derivative of 3 to the x. So that base has got to be 3. Next, what I notice is that all these denominators have ln 10. So I can eliminate all of them by multiplying through. So the ln 10 is actually going to cancel out of all these. Okay, so I can just do ln 10, I'm going to cancel this one, cancel that one, cancel this one, and cancel that one. That all cancels out because you have ln 10 over ln 10. If you were to multiply all the way through, that would all cancel out. So now the last thing, once all those are gone, I'm just going to simplify what's left here. So I have cosine over cosine, or cosine over sine is going to be cotangent x. So cotangent x I have there. This, I can cancel out the secants. So I'm left with just tangent x. Over here, I can cancel out the e to the x's, and that's going to give me a 1. I still got to put a 1 there because that's the coefficients in front. 1 over 1 is 1. And then this, I get the 3 to the x's are going to cancel, but I'm left with the minus ln 3. So again, the first thing I did, I canceled out all the ln 10s. And then, at that point, I did the identity. Cosine over sine is cotangent. Secants cancel. E to the x's cancel. I get these two things. 3 to the x's cancel, and I get this. So this right here would be the final reduced answer. We're going to find the derivative of theta, and then we have log base 2e, and then you have all this. Let's do some properties first. We can make this problem a lot easier by applying log properties. First thing is we're going to take this whole thing, move it down front. So I have theta that's already there already, but I'll multiply it by cosine theta and then times ln 2, and then I have a log base 2 of e left over. Okay, so that's the first thing. I was able to bring all that down. Now this part is a constant, so let's work with this one. Log base 2 of e. I'm going to apply the change of base formula on that. And so particularly I'm going to use ln because I have an ln here. So I'm going to do that on the side. Log e of 2, that's the same thing as ln of e over ln of 2. Again, change of base formula allows you to change this into any base you want. I'm purposely choosing natural log here. So I have theta times cosine theta, and then I have ln 2. This whole part here, I did this on the side, and I changed it to natural log of e over natural log of 2. What we notice there is that the natural log of 2's, those are both going to cancel out. And then what is ln e? Ln e is equal to 1. So the whole problem turns into theta times cosine theta, and that's it. There's no more logs, no more e's. We just have this. So to do this derivative, which is going to be a normal product rule, first thing is theta times derivative of cosine is negative sine, plus the second thing is cosine, and then times the derivative of the first, derivative of theta is 1. So no logs to deal with because I got rid of all of them. Normal product rule, first derivative of the second, plus the second derivative of the first. We can do some simplifying on that, and it's going to be cosine theta minus theta sine theta, if you want to write it this way, as a minus, and then that's as far as we can go with our answer. So this looks complicated, but the actual answer is just this one down here, cosine minus theta sine theta.